Hi guys, welcome back to the channel. In this video we are going to discuss serial in parallel out shift register. So let's get started. Out of all 4 shift registers, in the previous video we have already covered serial in serial out register. So that is SIPO register. In this video we are going to cover serial in parallel out type of shift register. SIPO we can simply call it as. So the name itself suggests it is a serial input. We are going to take the inputs as in a serial format to all the flip-flops as shown there. So all the flip-flops if you represent in a boxed format, so that is the representation. And you are going to take all the outputs in a one single clock cycle as a parallel output. In the serial in, not only you can insert the data from left to right, you can also insert the data from right to left. That is also a serial in process. But the out is parallel out. Both requires one clock cycle. That for popping out. For serial in requires 4 clock cycles. This is the circuit diagram that you can see over there. This is almost similar to the SISO shift register. A small change that we are taking output from the direct itself, output itself. So that you can see over there, that is D3 flip flop, that is MSB, that we have Q3 output. There itself we are taking Q3, Q2 there itself, Q1, Q0 there itself we are taking as outputs. So this is a small difference between SIPO, SISO shift registers. And we have the block diagram down over there. That input is one and we have many outputs, parallel outputs. So that is the one of the application, that is data conversion. We can convert the serial data to parallel data with the help of SIPO shift register. Now we are going to construct the truth table for the insertion of the input 1011 so that we can understand about application or the function of the SIPO shift register. Now we are going to insert 1011. For that, first of all we are going to have the clock as 0. If clock 0, input doesn't care. So all the outputs would be 0. In the same manner, now again we are going to insert the 1. Because after LSB the next only we are going to insert, that is also 1. So we are going to insert 1, and if you see, observe clearly how it is moving from left to right. All the bits. Even though they are moving, we are going to take the outputs from Q3, Q2, Q1, Q0 because these are parallel outputs. And now Q3 becomes our new one and a Q0 will be popped out. The previous output 0, Q0 is popped out 0. So the next one is also the LSB. After also the it is again we are going to insert the 1 itself because in the that is 1011 we are inserting. So the Q2 becomes the red one because that is moving towards right, and again we are going to insert 1. The next input you are going to pass in the D3 is that is 0. So after passing D0 as D3 as 0, so you can observe a movement towards right. So if you see clearly that Q0 is gradually popping out, means the zeros are popping out gradually. Finally, if you consider that we have the last one, that is MSB, that also we are going to pass as 1. So you can also observe that Q0 is popped out again. So the red one is coming to last, that is the Q0 as 1. So finally we got our required thing, that is 1011. I hope you understood the truth table, how you have to insert the given number or the given binary digit to the given flip-flop, that is SIPO. How we are going to take the outputs Q3, Q2, Q1, Q0 at the inputs with the outputs itself. Now we are going to draw the timing diagram analysis for that SIPO. So if you observe the truth table, we have the Q3 column and generally draw the clock for itself because every time we start we are going to draw with the clock itself. So if you observe Q3, that is 0, 11, so 0, 1. So you are not going to take 4, 0 because that is clock is 0. So don't consider that. So the thing is 11, 0, 1. So you have 2 high levels, 1 low level, 1 high level. According to that I formulated the Q3 timing diagram. In the same manner, if you observe the Q2 timing diagram, so the same. So 0, 11, 0. So you have 1 low level, 2 high levels, 1 low level. Like that it will going to follow. Basically, I am seeing the truth table and drawing this timing diagram. The next one is Q1 output. If you observe, we have only 2 ones in the last 2. So that is first 2 levels is 0, next 2 levels is high. Like that you can draw the timing diagram. Finally, for the last flip-flop, we have only 1 1 in the last position. For that, all the positions or the 3 levels would be 0, the last level would be 1. Like that, how many may be the flip-flops we have given. So based on output only, you are going to draw the timing diagram analysis. Now we are going to understand the things between SIPO and SISO, the difference we can say. So in SIPO, we are going to have or we are going to require n clock cycles for storing data. 0 clock cycles for use of data, n clocks for total processing. In a similar manner, if you want to compare with SISO that we have already discussed in the previous video, so simply seeing that n clock cycles for storing data, the same as SIPO, n minus 1 clock cycles for use of data. If you compare in SIPO, only 0 cycles for that, so it is advantageous for SIPO. And if you consider the processing time, that is 2n minus 1 clock cycles are required for SISO and only n clock cycles for total processing for SIPO. So from this you can compare both of them, SIPO, SISO, and you can know about which is better and which is not. And everyone has its own applications and its own uses. If you talk about SIPO shift register applications, so these are some applications of SIPO shift register. So the first one is data conversion that we have already discussed, that is from serial data to parallel data, and LED display, microprocessors, data transmission, data storage, control systems, address decoding, remote displays. So these are some applications you can read over there. So simply I am mentioning the headings. I hope you understood this video. Thanks for watching up to now.